Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Chris Flack.
Hey, Justin, thank you so much, and welcome everybody in our audience to today's webcast, Microsoft Clustered Storage Spaces and StarWind Virtual SAN for a complete software-defined storage solution, sponsored by StarWind Software. I'm Chris Flack with Virtualization Review, and I'm here to be your host for today's event, so thank you all for joining. I really appreciate you taking your time to do so. Now, just a few quick things before we get started with today's presentation and introduce our speakers. Just a few quick reminders that today's webcast is being recorded and archived for future viewing and listening purposes, and we'll send you a link to the email you registered with within 24 to 48 hours after today's presentation. We encourage you to share that link with coworkers, colleagues, and friends, anybody who may be interested on today's topic. We greatly appreciate that. Also, today's webcast will have a Q&A at the end. However, we encourage you at any time during today's presentation, if you have a question for either of the presenters, please feel free to enter your question via the Ask a Question box appearing on the left-hand side of your console. And hopefully, if time permits, we'll get to everybody's questions and get out some answers. Getting all that out of the way, I'd like to introduce today's presenters. Later on today, you're going to be hearing from Anatoly Vichinsky. He comes to us from StarWind Software. But first up today, you're going to hear from John Twigo. John is an independent consultant and well-known writer and speaker with over 30 years in IT. He's an author of 15 books on business automation topics and is an authority on business continuity, disaster recovery, and data management. He chairs the Data Management Institute, serves as the managing partner in the international consulting firm Twigo Partners International, and he writes the Infrastruggle blog at Virtualization Review and virtualizationreview.com. And with that, I'd like to hand everything over to John so he can get started with today's presentation. So I'll finish talking and hand it over to the guys. So John, why don't you take the floor?
All right. Thank you, Chris, and welcome everybody to today's webinar, which is covering Microsoft's software-defined storage approach based on their storage spaces technology. More to the point, we're going to be looking at how you can complement the Microsoft storage approach to what they're calling software-defined storage with virtual SAN technology, which is pioneered by StarWind Software. And that, in my view at least, delivers a more complete or comprehensive software-defined storage solution. Now, again, as Chris said, my name is John Twigo. I want to begin by thanking you for taking some time from your busy schedules to attend today's session, which is hosted by 1105 Media and sponsored by who I regard as one of the thought leaders in software-defined storage today, StarWind Software. And for about the next 20 minutes, I'm going to make some observations about the software-defined storage approach that's being advanced by Redmond. And specifically, I'm going to look at a few of the strengths and limitations of clustered storage spaces. And then I'm going to ask StarWind Software's Anatoly Vichinsky to help me understand the details of the innovative approach that his company's virtual SAN technology is providing that can augment and enhance or even substitute in some cases for the Microsoft clustered storage spaces approach. So, without further ado, hopefully I haven't crossed too many swords yet. We're going to get going here. All right. Now, it's probably a good idea to start things off with a quick refresh on some basic concepts and characteristics that have come to be associated with that term software-defined storage. Software-defined storage is, in fact, a really good marketing term because vendors can make it mean just about anything they want it to mean. Fundamentally, it refers to the creation of a Ooh, I'm getting a little bit of feedback here. Fundamentally, it refers to the creation of a universal storage controller in a software layer. So what you're doing is you're moving value-add services and software-based functionality that hardware array vendors have liked to run on their hardware storage array controllers for many years. And instead, you're going to take those software functions, you're going to move them off into a layer of software that will run on a server instead. And that reduces your storage kit to more or less a box of commodity storage devices, what we call a JBOD, or just a bunch of disks. Now, doing this is supposed to reduce the acquisition cost of the underlying storage hardware, and in theory at least, it's supposed to enable the easier allocation of capacity and value-add functionality when it comes to storage, storage services to specific application workloads, particularly those that have been virtualized in a virtual environment. And the strategy is also supposed to make it easier for a virtualization administrator who may have little or no knowledge of the technical details of storage to manage those storage resources and to ensure that application performance is not being constrained by storage-related issues. Okay, so that's kind of the dream of software-defined storage. Unfortunately, there's no agreed-upon strategy for doing this. There's no agreed-upon architecture or topology for delivering it to market. Just about every vendor in the SDS space has their own interpretation about how to deliver the goods, so to speak. That's led to the introduction of a wide variety of software-defined storage solutions that are in the market today. Now, for the purposes of analysis, I like to, basically winnow down all of the many complexities down to just a couple of key differentiators. As far as I'm concerned, what really separates the grain from the chaff in software-defined storage is two factors: hypervisor dependency and hardware dependency. Now, some hypervisor vendors, like VMware, for example, have built software-defined storage solutions that are designed to support only workloads that are hosted using that hypervisor. Their software-defined storage architecture is hypervisor dependent. It creates what we used to call isolated islands of storage that can only be accessed and used or shared among workloads that are running under the same hypervisor software stack. So what you're doing when you set up their particular configuration is you're wedding your storage to support only a particular kind of hypervisor. Not a problem if you're only using one, but more and more companies are diversifying using multiple hypervisors, so that may be a constraint that planners need to consider. Now, other approaches to delivering software-defined storage, usually coming from third-party software-defined storage vendors like StarWind Software, for example, are hypervisor agnostic. Now, StarWind and maybe a few others have gone to great pains to create virtual SAN software-defined storage solutions that work with several hypervisors and that enable the resulting storage to be more readily shared and used by different workloads. Now, that's what we call a hypervisor agnostic SDS. It's a good general differentiator you can use to sort through the various SDS offerings in the market. Do they depend on a particular hypervisor, or do they result in a storage infrastructure that can be shared among both virtual and, in some cases, non-virtualized applications in their data? Now, the other big differentiator is that line that's kind of moving across the bottom of the diagram you see on the right-hand side here. It has to do with hardware dependency. Now, the ideal software-defined storage solution is supposed to be completely hardware agnostic. That is, after you take all of the value-add software off of the proprietary array controller and you place that into that Uber controller, that software layer that's running on the server, SDS is supposed to work with the remaining commodity components, the storage capacity, if you will. So you're stripping away the value-add software, and everybody is basically just selling you a box of Seagate or Western Digital disk drives and perhaps whatever the popular du jour flavor is of flash technology at any given time. So despite the different manufacturers of these components, they all conform to the same protocols for operation and success. Your disk drives and your flash drives are probably SATA or SAS or maybe fiber channel compliant. So the SDS solution really shouldn't prefer one vendor's box of disk drives over any other vendor's box of disk drives. The constraint shouldn't be whose logo is on the side of the storage array. Now, unfortunately, some software-defined storage solutions are still very hardware dependent. You see this in what some vendors call their hyper-converged SDS storage hardware solutions, which are quite often proprietary hardware kits that are designed to work with a specific hypervisor. You also see a little bit of hardware dependency these days in some of the hypervisor vendor offerings in software-defined storage where the hypervisor vendor is offering his own virtual SAN that requires exclusive use of, say, only SAS drives or of a storage node hardware that's pre-certified, in air quotes, and branded by the vendor. You get the idea. The closer we come to workload and hardware agnosticism, the closer we are to the nirvana that we were expecting from software-defined storage. But there's there's a spectrum of solutions that aren't quite there. They aren't quite agnostic. Unfortunately, workload and hardware agnosticism aren't necessarily in line with a particular hypervisor or hardware vendor's revenue objectives. You know, we see a lot of variations on what qualifies as SDS, and the resulting architectures that work only with one hypervisor or with a few, or that use software-defined storage software layer to hold only certain value-add functions while leaving the hardware vendor to control other functions or to control capacity, services, etc. from its software layer. So if you're trying to define a storage architecture for your virtual server environment, it can be challenging just trying to figure out what the heck the software-defined storage vendor is actually trying to sell you, what he's talking about when he calls his stuff software-defined storage. So that's why I guess that's the long way of getting to the point here, which is as we look at Microsoft's solutions in this space, we're essentially trying to figure out, what's real, what isn't, what they're calling software-defined storage, and what meaning they associate with that versus what meaning you may have in the back of your head as a representation of what you think software-defined storage is. Anyway, today we're here to talk about Microsoft's SDS Play, its software-defined storage solution, which is aimed at server infrastructure that has been virtualized using Hyper-V technology. Now, in 2012, Microsoft started talking about software-defined storage mainly in the context of VMware's numerous approaches to dealing with its storage problems. Now, interestingly, Redmond used its marketing to villainize, its rival, VMware, stating that it might very well have been their hypervisor code that was the source of application performance issues that they were attributing to storage I/O processing problems. And as a result, VMware was recommending that customers rip and replace their infrastructure and replace it with either more expensive hyper-converged storage or ultimately their version of a virtual SAN. Now, in response, Microsoft introduced a new storage technology of its own. It was based on something called storage spaces that they had introduced in Windows Server 2012. And they claimed that it would dramatically reduce storage costs by eliminating the need for expensive brand-named hardware. Now, the new technology was called clustered storage spaces, and it could be used to build, according to Microsoft, a massive storage complex behind Hyper-V servers that could scale out without the high price tag associated with, say, high-end brand-name NAS or even SAN storage. So the resulting infrastructure, they said, was going to use SAS disk, that's serial attached storage, and it would support server-side memory-based storage, such as flash, which was taking on increased importance, and it would also avail itself of Microsoft's new SMB 3.0 protocol for ease of connectivity, and they promised that protocol would deliver nearly the same performance as fiber channels. So, it looked like it was going to have the speeds and feeds and the capabilities to be able to support everything they wanted to do. Basically, the resulting storage would be presented as a set of pooled resilient LUNs, what they called storage spaces. And you could leverage Windows clustering services and Windows file systems, such as NTFS, if you wanted to make the infrastructure resilient and highly available, or if you wanted to present the storage as a general purpose file server repository. Now, the result, in one writer's words, was a virtual storage appliance that could be built using your existing server hardware, the stuff you decommissioned when you consolidated all your applications onto more robust servers for hosting. You could take that older hardware and you could use it as storage heads, if you will, where storage spaces could be configured and you could attach internal and external storage devices. As a bonus, the platform was going to provide a way to convert or migrate virtual machines formatted to run with VMware over onto a Microsoft Hyper-V environment. So, that was at no additional cost. Rather than sharing the storage natively, when you moved a VM from VMware, you were going to store it on your Hyper-V clustered storage spaces platform, actually as a Hyper-V VHD. We were going to convert everybody over that way, I guess. Now, said Redmond's evangelist, the resulting storage availed itself of all the ongoing improvements that Redmond was making at the time to its SMB 3.0 protocol, including transparent failover and SMB direct and multi-channel access. According to analysts engaged by the vendor, to estimate the value of their product. Storage spaces over SMB was touted as the way to deliver nearly the same performance, within 1 to 4% of the performance of traditional fiber channel storage solutions, but at approximately 1/2 of the cost. Now, there are different views whether this total cost of ownership claim, is valid, and let's leave that for a deep dive discussion of Microsoft software-defined storage that we're probably going to have here again and again and again over time. In fact, right now you're hearing a little bit of, I'll preview a little bit. You're hearing some discussion of Windows Server 10. And some innovative new things that they're doing in Windows Server 10 to try to resolve some of the issues that we'll be pointing out a little later on. So Microsoft is pretty much, it's got its feet on this particular space. I went through it all rather quickly, so let me just reiterate the key points. First, clustered storage spaces leverages technologies that were first released in Windows Server 2012, including clustering services and storage spaces. And they've leveraged these technologies to introduce basically two topologies for storage. One is clustered storage spaces simply, which is intended to provide a highly available block storage pool behind newer existing implementations of Hyper-V. Basically any of Microsoft's enterprise applications that use block storage, including SQL Server, Exchange, etc., will be able to write their blocks or hybrid blocks or file data to that kind of a repository. Now, the other implementation of this technology is basically the same thing, but you add in file services. So what you end up with is a huge scalable file server that's a cobble of clustered storage spaces and file server technology that was introduced in Microsoft Server 2012. And then if I drill down just a little bit further, here is the technology being used to create large block storage pools using SAS JBOD arrays to interconnect the Microsoft Windows Server 2012 via SAS protocol to the back-end storage. And these are basically these pools or storage spaces present their LUNs for allocation and use by any workload that's virtualized or that has access to the storage. Now, clustering services are used to facilitate the creation of failover clusters between nodes of storage, with data replicated between the storage on different nodes at or near the time of write. So what we're trying to do is create a highly available storage infrastructure by replicating data on each node and then establishing a relationship between the nodes. So if one node fails, the other node picks up the work, or the work itself is already distributed across nodes in an active-active configuration. There is no RAID in this configuration. There's no need to set up tiering between solid-state storage devices and hard disk drives. Microsoft already has something called hot blocks that will automatically be moved from SSD or from disk into SSD to improve performance if you set that up as a tiering strategy at the time that you create your storage pool. So you've got some cool functionality, usually the same server node, or on separate servers connecting to the storage nodes. One or more applications are loaded, whether they're virtual applications using Hyper-V or native apps running on physical hardware. And the clustered storage space can be shared. It looks somewhat like what you see in this illustration here. It's presenting itself as a pool, as a virtualization of the underlying hardware nodes. Okay, so that, if I haven't completely confused everybody, basically that's your standard block storage environment with some fairly capable storage controls that you would normally find on a high-end array controller if you're doing this with hardware. And basically it facilitates the use of the resulting pool by numerous applications. I also said that we can use the same technology, overlay it with some of Microsoft's file services to create a Microsoft-branded scalable file server cluster that can serve up file storage to multiple servers. And again, this is a shared storage meme, which means that it isn't necessarily isolated islands of storage like you find with some of the other solutions that are out there. Scalable file server clustering provides the ability to share the block storage like SAS via Microsoft's Network File System Protocol, which is SMB 3.0. That provides a very scalable NAS-like solution that's created mostly from commodity components, and it can support shifting workloads and virtual server clustering that's done in the Microsoft Hyper-V way, and also the workloads or the file system requirements, or file service requirements of numerous non-virtualized applications as well. Now that pretty much, according to Microsoft, results in an infrastructure that clearly qualifies for as a kind of software-defined storage. After all, services that are normally provided on array controllers for functions like resiliency levels and thin provisioning and memory-based read caching and SMB copy offloading, snapshotting, cloning, 2- and 3-way mirroring, even data tiering using solid-state drives and data deduplication can be supported using this. So you're talking about a fairly sophisticated software-based controller that Microsoft is providing here. And Redmond boasts, of course, that its software-defined storage solution offers all the capabilities and functions that could previously be found only on expensive proprietary storage arrays. There's a laundry list of them here, a set of bullet points. Basically, you think about the things you pay a lot for if you go out and you buy hardware with specialty software on it, things like deduplication or other kinds of write-back caching for performance optimization, snapshots and clones and that sort of thing. You're going to pay a lot of money as a value add on commodity disk. Now you're getting that functionality as part of the Microsoft software stack. And basically Microsoft says you can serve up either shared block or shared file service using commodity hardware and Windows Server storage spaces and clustering for a fraction of the price that a NAS appliance would cost you, or an EMC or a NetApp or a black box array that you would put in a SAN. And given the extremely low price tag for commodity gear and the software that you need to build a clustered storage space, Microsoft says that it blows the socks off of VMware as well. So that's basically its business value case, and they also say, in addition to their competitor hypervisor, they also blow the socks off of most legacy array hardware as well. Now, that all has its upsides and its downsides depending on who you ask. There are some known issues. I did a quick survey of the chatter among engineers and operators who participate in TechNet and found several issues that are garnering a lot of attention right now. For me, I was initially concerned about whether or not the Microsoft approach actually satisfied the definition of software-defined storage. And the purists out there, of course, say that it doesn't. They generally don't like any software-defined storage offering. But in the case of Microsoft, they say, look, first of all, you got a heavy hardware requirement in the form of an all-SAS environment. Microsoft doesn't natively support SATA drives. You can only use serial-attached storage drives and disk arrays that are built from those. And technically speaking, this doesn't completely segregate storage services from storage hardware. So that makes it a cobble and only partly hardware agnostic. Now, another agnosticism complaint that I've read is that, while Microsoft touts active-active high availability clustering as a solution that it supports, in fact, active-active clustering is only supported if each node in the cluster has a SAS JBOD hanging off the back of it. The storage has to be external. As soon as you include internal storage that's mounted right on the main board of the server, and you add that to the mix, you're restricted to only active-passive clustering. Now, this is still pretty good from the standpoint of availability, but it does not enable the seamless, transparent rehosting of virtual workload that the active-active advocates are looking for. Now, interestingly, many criticize how Microsoft uses Flash, both in terms of write caching and especially in terms of how flash storage is used in its deduplication functionality. Now, this goes less to the purity of this as a software-defined storage solution than to the more practical issues of how well this solution is going to perform and how it's going to deliver the goods in terms of efficiency. Now, in both cases, flash memory is not very efficiently used. At this point, I think everybody on this call probably knows that flash is vulnerable to memory wear. And what happens is, when you write a cell in a multi-layer cell environment beyond its maximum, which is somewhere around 250,000 writes in a cell location, basically you have to you burn out the cell, and you have to decommission that cell plus the group of cells that it is to which it belongs. Now, over time, when this happens often enough dead and unusable groups of cells translate to a dead flash device that needs to be, replaced or worked around. Now, that's not a big deal as long as it happens within the time frame parameters that you expect of a disk drive, let's say. But when it happens at an accelerated rate, you can really jack up the cost of the underlying infrastructure because you find yourself replacing flash devices more often than you thought you would. Microsoft doesn't write to flash with any consideration, as nearly as I can tell, to the vulnerability of flash to wear. Make small block writes, lots of them. Every time you do a small block write, you have to refresh a page of memory. You end up basically writing and writing and writing for lots and lots of small blocks, and you're going to reach that 250,000 write per cell location threshold very rapidly. That's a problem. And it's also aggravated by the fact that when Microsoft does deduplication, if you designate that you have flash devices in the server, it originally writes the data it's going to deduplicate into flash, and then it proceeds to go through that the processes that it uses to deduplicate that data, which is also exposes the flash to excess wear. So again, the complaint of the engineers is that they don't think that you're using flash very efficiently with clustered storage spaces, and that's a concern. And then there are several other issues, minor ones that get reported from time to time on TechNet. One has to do with Microsoft's thin provisioning methodology, which requires you to over-provision your storage. You actually have to buy more storage than you need so that you can respond when you get a message, an error message saying that, hey, you're going to run out of space. If you haven't got the space available, it can spoil your whole day. You could have a career-limiting event when things shut down. So they're saying, that kind of defeats the purpose of having thin provisioning if I have to field a lot more storage than I need in order to protect against the possibility of running out of storage. I would say that that's probably a problem with thin provisioning generally, but I kind of understand where they're coming from. They don't like the implementation of thin provisioning in the software control that Microsoft has built. Nor are they typically very happy with the implementation that Microsoft has made of what they're calling parity striping. They have different ways to protect data. You can create parity striping on a disk and basically protect your data that way. It's all done, it's almost like they've moved RAID technology off the array controller and into Microsoft world, and now Microsoft's software layer is going to control whether you're using parity or you're using other methods to protect your data. That's an interesting approach, but they say that it drives you ultimately to having to go to two-way mirroring as the only real protection that you can do. Parity striping, requires two-way mirroring for performance reasons when you start to cluster, and that increases the amount of storage capacity demand in your environment, increases the cost of your storage infrastructure by as much as 300 to 650%, depending on whether you read IDC or Gartner. So, in highly virtualized environments, if you're going to mirror everything and you're going to have to do two-way mirroring, you're going to have to really blow the socks off of your storage capacity budget in order to make it real. Now, even Microsoft has its limits. I mean, let's face it, there are a lot of capabilities in the Microsoft software controller and its clustered storage spaces. They are even admitting that some of these issues exist. They're talking about Windows Server 10, and they're saying that in 10 they're going to go to a shared nothing cluster arrangement, kind of a new version of clustered storage spaces that are going to resolve some of the issues. We'll talk about that with Anatoly a little later on. But bottom line is they're acknowledging that there are some deficits, and before they started talking cryptically as it is about Windows Server 10 and what's going to be in there, it led some of us to start looking to see whether there were any other technologies out there that we could use to complement what Microsoft was doing that would address and resolve some of the issues. What if there could be a Microsoft clustered storage spaces enhancement that would allow me to use SATA disk as well as SAS, or allow me to use PCIe flash, on the motherboard? what if we could deploy an augment to clustered storage spaces that would let us use 40-plus gigabit Ethernet, so we could really get some high speed going in our storage environment? And what if we could support real active clustering and maybe use a log structured file system that would enable efficient write caching so that we didn't burn out our flash? We would impose a lot less wear on our flash. And what if there was a technology that would enable us to hold on to our legacy gear, keep it in service for a little bit longer so we get more use out of it since we paid so much for it? I mean, one of the things that really boggles a lot of my clients when I go there is that the same vendor who just sold them the SAN, last year is now telling them that's legacy gear and it needs to be ripped and replaced for their new virtual server environment. That's driving everyone crazy. So would such a technology compete with Microsoft clustered storage spaces, or could you simply use it to complement and enhance the capabilities of Microsoft's software-defined storage? Now, to get to the core of this, I want to go to StarWind Software. StarWind's been promoting virtual SAN technology for several years that predates both the VMware interpretation of that and also Microsoft's approaches to software-defined storage. In my humble opinion, it appears to provide a lot of powerful and worthwhile enhancements to the story that Microsoft is already telling. And we're fortunate today to have with us an expert from StarWind Software. His name is Anatoly Vilchinsky. He's my new best friend. He supports he heads the support department at StarWind Software. And Anatoly has worked for 6 years in quality assurance and in technical support at that company. And prior to that time, he was for 7 years employed in business IT departments. So he's seen some of the challenges of the real world IT from the consumer side, and he also has worked obviously in the vendor side. Now, if you recognize his voice once I give him a chance to talk, it'll probably be because Anatoly is also the host of StarWind's own technical webinar series, which I strongly recommend you attend if you want to learn more about their product. Hello, Anatoly, and let's get down to our chat. Are you ready to go?
I'm definitely in. So hi, John. Thank you for a really great presentation. I really appreciate it, and I'm really happy to be here. I'd like to say that you did an awesome job on summarizing some of the capabilities of StarWind Software Virtual SAN and how it can be leveraged with Microsoft Hyper-V environments. And obviously, you make a really great presentation of cluster storage spaces with all the process gone. So,
all right, you're turning my head. I'll tell you what. Let's back into it this way. Give us the 2-minute elevator pitch or the little backgrounder on StarWind Software. I just threw up a slide that has some bullet points on us. Tell us very succinctly, if you could, a little bit about StarWind Software for the people on the call who may not be familiar with your company.
No problem. So StarWind Software was founded in 2003, and basically it was spin-off from the Rocket Division Software. We have more than 30,000 users, including the ones from the Fortune 500. We've got a headquarters in Wakefield, Massachusetts, USA, and actually we have an office in Kyiv, Ukraine as well. And we have more than almost 300 channel partners, and we're technology partners with the Microsoft, VMware, HP, IBM, Dell, a lot of big guys actually in the market.
Okay. Well, thanks for that summary. Now, we've been talking about an approach that Microsoft has taken to software-defined storage, their clustered storage spaces architecture. Now, first off, can you give me an answer to a question I keep getting when I talk to people about StarWind Virtual SAN? They always say to me that Microsoft is delivering its clustered storage spaces stack for free with Windows Server 2012 or at a nominal cost depending on which integrator they're working with. And they want to know why you'd want to add third-party software to a pre-integrated stack. What do you see as the key value of bringing StarWind into the mix?
Great question. So the key point of our company is that we don't want people to spend too much cost on their IT infrastructure. So if you may remember, one of the known issues of the Microsoft technologies was that it can use only SAS JBoss, which can be called proprietary hardware, and that's, as you said previously, against the software-defined storage ideology. And also it requires having even more external JBots to run the active environment. And that is StarWind actually fixing. StarWind is a true hardware agnostic. It doesn't require having anything proprietary, so it can run on a usual SAS spindles, SATA spindles. It can utilize flash drives. It can, it doesn't require having SAS cables, obviously, since you are not since you're not married with the SAS technology at all. With StarWind, all of those cuts down the CapEx and OpEx.
Mm-hmm. Well, let me ask you to clarify something for me. Does StarWind, I'm looking at one of your diagrams right now, and it's kind of not clear to me. Does StarWind install as a virtual machine? Is it a storage mount? Does it replace clustered storage spaces? How does it integrate with their stack?
StarWind can replace the storage spaces when talking about the shared storage, because StarWind actually does the shared storage. And it can run as the back end of the storage space, as SMB3 actually. And the first question was how exactly StarWind is configuring, and StarWind is installing not as a virtual appliance. It runs on the same partition with the, let's say, Hyper-V.
Okay. All right. So it's merely a storage resource that can be leveraged by Hyper-V, or do you run clustered storage spaces on top of it if you prefer?
Yeah, exactly. So, StarWind is the multi-node thing. So if you will take a closer look on this particular diagram that we are on right now, it shows actually the implementation of the SOFs, of the scalar file storage, scalar file server. This is how the minimalistic setup of the Microsoft technology looks like. So let's make a quick recap. You need to have at least 4 servers. Each of them should have at least 3 network interface cards. And also, 2 of those servers should have 3 JBots connected, which obviously requires having 3 JBots, 3 SAS HBAs on each of those 2 servers. That will cost a fortune. That makes the budget go through the roof. And if we will compare these with the minimalistic footprint of StarWind, which can be found on one of the previous slides.
Okay, so as the previous slide, I'll go back there. Okay, here we've much simplified. Oh, went forward. I'm so sorry. Here we've much simplified the infrastructure by simply putting all the storage, the JBods behind the primary, the Hyper-V servers, but we're running your software on there to basically grab all that storage and present it for use by either Hyper-V directly or clustered storage spaces, if that's how we want to slice and dice it. Now, one of the things I've read over and over again in your white papers is that you're able to scale the storage independently of the applications or virtual workload. That if you scale the amount of StarWind controlled storage capacity, you don't have to change anything about the way the applications access the storage, that you're basically insulating the application. Can you talk to that just for a couple of seconds for us?
Sure thing. So, the good thing that I'd like to mention before I'll dive deeper into the answer is that StarWind is not actually the hypervisor agnostic. It's client application agnostic, because it can be used with the Hyper-V, with the VMware, Citrix, KVM, Proxmox. You know how the list is big, right?
Sure.
So regarding your particular question, StarWind, one of the great benefits of StarWind solution is that it can be easily scaled. So, for example, if you want to dedicate some part of StarWind storage or some part of the disk space that StarWind utilizes to create the shared storage that works over a SCSI protocol, then go ahead. I mean, that's easy. In a couple of clicks, you can create the shared storage using the disk space, the amount of disk space that you want, and share it to the application that you want. If you have another application that you want to use simultaneously with the previous one, and it requires shared storage, go ahead, no problem at all. You have mentioned on one of the known issues of Microsoft that it has some problems with the SIM provisioning. Well, guess what? StarWind doesn't. So StarWind SIM provisioning utilizes the amount of disk space that you are actually using without any negative aspects, any negative effects, or some consequences. So
let me jump in real quick and dissect that, because I think you're putting together a lot of good points here, but they're getting kind of blurry.
Maybe.
I can scale up, meaning increasing the capacity inside of JBOD if I can use SATA drives, right? I mean, they have higher capacity, so you're enabling that. I'm also able, one of the drawbacks of clustered storage spaces was that once you started using internal storage components, you couldn't do active-active clustering. You can actually accomplish active-active clustering with a componentry that includes internal, say, RAM and flash RAM together with disk, and also external JBODs. And then finally, I had mentioned in my presentation, you haven't talked to it yet, that you're actually preserving the investment in flash, because you have something called log structuring that will enable me to use that flash in a better way. Let me. In fact, I want to dwell on log structuring a minute, because that is a huge differentiator in my view. Can you talk to us a little bit? I've thrown up the diagram that I pulled out of one of your white papers online that talks about the benefits of log structuring. Without going too deeply into it, can you give me an idea of what's going on here?
Sure thing. Log structuring is a really breakthrough technology from StarWind. No, at least we want to believe so. So what it does, okay, I'll tell you how it works, and then I will tell you the benefits, the good things as a result. So StarWind grabs the multiple small random writes generated by the hypervisor, and it converts it into the stream of a big sequential writes.
Okay.
Well, also it logs.
And it uses to hold all the small writes. It uses dynamic RAM inside the server.
Exactly. The randomization technology. Yeah. So obviously the StarWind device, the StarWind log structuring file system is supplied with L1 cache and L2 cache, and also it works with the duplication, which is, by the way, works inline compared to Microsoft offline duplication.
Right.
Okay, so
so and then you're able to cache that all to flash devices and let it trickle down to the back end disk storage at its own pace, but it gives the impression to your application that the write has been made, so it can go on about its business. So what you're doing is you're speeding up application performance without killing your flash drives, and that makes all kinds of sense to me. Now, the last issue that I want to deal with before I open this up for questions, I'm trying to save us some time for audience questions, which I see are mounting up in the Q&A panel right now. One of the things that impressed me when I sat for the demo of your product was centralized management that's offered by the product. Can you spend the last couple of minutes here before we go to audience Q&A to talk about how you manage the underlying storage infrastructure and how you make it simpler for maybe a storage or a virtualization administrator who doesn't really understand a lot of the nuances of storage, makes it easier for them to make sure that they're keeping track of how it's working and the allocation and deallocation of the resources to the workload.
Sure. We offer a full suite of management capabilities. It's a list of the functionality that's on the screen. How do you ensure that your nodes are all operating properly? That actually, if you StarWind Management Console is the centralized thing that helps to manage all the StarWind nodes and all the StarWind devices. It can be installed on any laptop in the network, in the LAN, and you can manage it actually even from home. It gives the ability to control the size of the storage, control its state, make some reconfiguration, change the size once again, maybe remove the HA partner, add it back again, change the network interfaces. It helps you to monitor the performance of your storage basing on the IOPS or the throughput, let's say. Obviously, it gives you health monitoring ability. You can you check the health status by viewing the event log or the server log. And you can obviously increase the security of the storage system by changing the access right through the access rights tab. That's in the middle of the list among the tabs on the screenshot, or configuring the CHAP permissions. CHAP stands for Challenge Handshake Application Protocol.
Right. So you can set up all the replication that you're going to be doing. You can set up the clustering you're going to be doing. You can set up you can monitor the state and condition and health of the at the device level, at the JBOD level, at the internal component level, and you can see whether you've got any kinds of problems or any burgeoning capacity requirements. Frankly, I'm intrigued by that, and I usually think management is the first thing we ought to look at when we're thinking about deploying storage. Now, for the audience that can't really see the print here, how can they test this out? Can they download your software and try it out to see how it will enhance the capabilities they have in Microsoft's Hyper-V environment?
Of course. People can download the free trial. It's for 30 days. People can download our free version, actually, which is perpetual. And if there are some Microsoft certified professionals, they can get a free NFR copy.
Oh, wonderful. Okay. I believe we have a slide listing for a lot of these URLs and actually a location where you can pull down the trial copy. We'll show that while we're doing the Q&A. Mm-hmm. So at this point, what I want to do is, actually one last note. I mentioned Windows 10 Server and storage spaces shared nothing architecture. Can you embellish it all on what I'm hearing there? I mean, I've heard that Microsoft is going to use this as a way to address some of its issues, including the ability to use SATA and PCIe and NVMe flash, and basically to create clusters that are shared nothing clusters where the nodes, I believe they require 4 nodes in that cluster as well. Yeah, what are you hearing about this? And my question would be, well, if this new architecture solves all the problems we cited earlier, does it limit or eliminate the need to deploy your virtual SAN?
It doesn't. Well, StarWind Virtual SAN can do the shared nothing clustering for years. It does support even 2 or 3 node configuration, and of course supports hyper-converged configs. The first stumblestone from the Microsoft standpoint that I see is that it still hasn't been developed, and it will take time. So once Microsoft will come up with some new technology products, whatever they will call it, StarWind will have another one that will,
So you'll still be a step or 2 ahead of them, even when they finally deliver it.
Exactly. Time is our friend in here.
I like your confidence. Okay, very good. Now it's time to go to Q&A, and I'd like to thank those in the audience for participating in today's discussion. Please use the Ask a Question tab down in the lower part, I believe, of your audience screen if you have a question. I see that we already have a few in, so I'm going to jump right into Q&A. I'm going to assume that most of these are for you, Anatoly. So first of all, does your management console report on application performance? Do you do end-to-end analysis of application performance and I/O storage?
Yes, it does. It can show the IOPS or megabytes per second for whole entire server or node, or it can show the performance of one particular logical unit. Both actually are working pretty good, and it logs the performance for the last 24 hours, which is good as well. Well, that's mostly it. Well, except a little bit insider information for you guys. We're working on getting a little bit extended login, so it would capture the performance numbers for, let's say, a week or something.
Wonderful. Steve, a fellow wrote in, and he's corrected me, and he's absolutely right. SAS actually stands for Serial Attached SCSI. I think it was Serial Attached Storage or something that I said. My apologies for that. Okay. Secondly, let's see. Are you doing I/O coalescing with your log structuring, your log structured file system? Is that what log structuring actually accomplishes, coalescing the I/O and writing?
Yeah, I get it. I think it's you pronounce it like coalescing. Well, no matter. So yeah, that's basically what LSFS is doing. So it coalesces the small writes into big writes. It converts the random IOs into sequential IOs. Thus, it increases the speed of the process, and since there is a big write, it will affect multiple spindles of parity rates. Thus, StarWind turns the terabytes into IOPS.
Well, I'm less politically correct, and I call it spoofing. Okay, basically what we're doing is we're taking all the writes that would normally wear out your SSD and instead, or PCIe flash card if that's what you're targeting, and instead we temporarily hold them in a DRAM environment until we can coalesce all the writes and write them in a much more sequential manner down to the storage device, and that will reduce the randomization of the data and improve the performance of the storage. But even in the meantime, it spoofs the application to thinking that it's already written to the storage. It's essentially, it's akin to what NetApp was doing with its write buffers in order to make NetApp filers work at all well. I want to dwell on it, but there isn't. We did a whole talk on log structured file system and StarWind technology. The last webinar we did about 2-3 weeks ago, and I'd recommend to the listener that he find that. In fact, if the people from 1105 would be nice enough to send him the link, he can actually play the replay, and it's a very in-depth discussion. Now, here's another, I think, a very important question somebody's asked. What kind of alarms does StarWind have? Can it mail alerts? Does it have SNMP capability so we can monitor StarWind storage together with other devices, right?
Yeah, good question actually, and answer is obviously yes. StarWind can do all of those things. StarWind can generate you the event notification about the, let's say, about the HA device going unsynchronized, about some, let's say you're running in some provisioning device and you are almost out of the disk space. You will get the email notification for that case as well. By the way, a little hint for you guys: if a lot of people are configuring that email notification to go through the Gmail, and then Gmail sends them SMS notifications, shared messages. which is pretty convenient.
Another question, this one's near and dear to my heart because it's exactly what I did when I downloaded your software. This fellow writes in, so for a small lab system, all I need are 2 Windows Server 2012 systems, R2 boxes, with lots of internal SATA storage on each one and a 1 gigabit NIC on each box and StarWind software. And that will get me active for both typical file shares and Hyper-V loads?
Great question as well, actually. The answer is yes, almost. Everything fits except you need to have at least two network interface cards on each server. That's mostly it. That's one of the biggest benefits of StarWind as well. So with having only 2 servers, you will have the fault tolerance shared storage cluster, and you will have highly available Hyper-V cluster, let's say.
Okay, and I guess this will be our last question, but I want to assure everybody whatever questions we didn't get to, we will be able to follow up in email later on. Explain a little bit more about how your data mirroring works. Does the gear that you have virtualized need to be of the same type, or can I use SATA disks to back up SAS disks or to mirror the data on SAS? Do the nodal configurations need to be identical in every node? For mirroring to work?
Identical, no. Similar, yes. But even here, it's not a requirement. So let me give you a little bit of explanation on this. The StarWind will work with the speed of the slowest node. So if you will have 40 gig supplies server with all flash storage on one side and 1 gig network interface cards with 7200 spindles on the other, that will work with the speed of the second one, and that is something that you didn't want. So you should better equip the servers approximately similar, not identical. But even if you have a symmetrical configuration, StarWind does support the ALUA technology, which stands for Asymmetrical Logical Unit Access, which basically uses only fastest node in the cluster, and that is not slowing down whole environment.
All right. Well, I'll tell you what, I promised to do this. I should have had it on the whole time that we were talking, but here are a number of links that the attendees can use. In addition to getting more information about your product, they can also download using these links the 30-day free trial that is available for your software. So I encourage everyone who's on the call, if you have an interest in this product, try it before you buy it, and I recommend that with every product that's out there. But Anatoly, thank you very much for the illumination you provided on the subjects here today, and I want to thank everybody who took time out of their busy schedules to be part of today's discussion. And now I'm going to turn things back over to Chris, and Chris, let's take us out.
Yeah, thank you so much, John and Anatoly. Thank you guys for your presentations today and taking an hour out of your days to join us for the presentation. Very appreciated. And a big thank you to everybody in the audience for joining us for today's webcast, Microsoft's Clustered Storage Spaces and StarWind Virtual SAN for a complete software-defined solution. I'm Chris Black with Virtualization Review. Thank you so much for joining today's webcast. We hope you have a great day. Take care, everybody. Bye now.